Okay, so I'm going to look at the drill for this one. So there's a couple of things that we need to be able to do before we start adding and subtracting fractions. So one of the things we need to be able to do is to manipulate improper fractions and mixed numbers, right? So just really quick, just to review. I wish no, I'll do it right. I'll just write it right here. So when we cover, improper fractions, right? So let me show you an example. We have two types of fractions usually that we deal with at the beginning. We have proper fractions and improper fractions, okay? So I'll put an example here. When I don't have, so here I have proper, right? So here's a proper fraction. Now, a proper fraction is, you may have seen this, right? So a proper fraction may be something like 4/5, right? So with a proper fraction, what's happening is that the numerator, right, is less, right? So the numerator is less than the denominator, right? So the denominator is greater. And this just goes out to the folks that are a part of the Green Cadre. I am recording this. This will be posted on YouTube, so any audio that I capture will be also captured on that. So just letting you know. So we have something called improper. Where it's kind of backwards, right? So I'm just going to flip it around. So we have 5/4, which is kind of already looking weird. In this one, it's backwards, right? So the numerator is greater. Right? And the denominator is less. Okay. Now, so let me tell you something about fractions really quick. Now, when we're dealing with fractions, right? Just remember when we hit this point right here, so I'll put this in black. When we hit this point right here, like 5/5, we've come to a point where this fraction is complete, right? So meaning that if 5 is the maximum, right? And so if you think of it like a puzzle, right? Let's say it's like a really easy like preschool puzzle that only has 5 pieces. Well, there's only 5 spaces. And that means that all 5 pieces are in place, right? So all the spaces are taken up, which means that your puzzle, right? So which means that your puzzle is complete. So you have one whole puzzle. Okay. Hey, Karanji,
Good morning,
how's it
Mr.
going?
Good.
Good work. Your high score.
So just so you know, you are you just checking in? Are you hanging out? Just wondering, just because today we're covering math, so I'm just making sure you're doing okay.
Okay, so I'm independent work for the reading.
Reading is next Monday and Tuesday, so that's what we're doing. So reading's Monday and Tuesday.
Yes, I understand. So now I'm log out my class and then I go to for Aztec and independent reading class. If it's okay.
Yeah, that's fine. Yeah, absolutely. And actually, if you want to stay on and if you have any questions about the reading, let me know. You can interrupt. I don't mind. Just, I mean, I know I'm working on math, but if you have any questions about the reading, just kind of raise your hand and I can, I'll take a couple minutes out you know, to help you out. Okay?
Okay, thank you, Mr. Gomez.
Okay, cool. All right. And I see Vanessa's come in. All right, cool. So we're talking about fractions, about kind of like the nature of, some of the fractions that we're dealing with. So when we have like something like 5/5 or 2/2 or, whatever, if the numerator and denominator are the same, that equals one. That's one whole. Everything is all together, right? Now, however, once everything is in balance, what I'm trying to say, right? But once you start going in one direction or the other, right? So in this direction, it's not balanced because you're missing a piece, right? Or you're missing pieces. And then in this direction, well, guess what? It's too heavy on one side because that 5 is more than 4. So think about like you're filling an ice tray, right? So let's say you're making ice, right? And let's say you have it's a small ice tray. Let's say it's one of those like party ones where like maybe it's for a Halloween party or something. Like, ooh, these ice cubes look like spiders. Ooh, spooky, right? And so you have 4 like places to put water. Well, if you have enough water for 5 ice cubes, guess what? You got too much water and it's going to spill over. It means you have more than one, right? So that's really what's happening here. So whenever you are going in this direction, like towards improper fractions, that means you have more than one. Oh, let me repeat that. When you go into the improper fraction side, that means you have more than one. Okay. Now there's another way to represent that though, right? There is another way to represent that. And the way we represent that, and if you've made cooked or baked or anything like that, you've seen mixed numbers. So we use mixed numbers when we get to the point where we have more than one, but we still have some left over, right? Just like when you're making ice cubes, guess what? Well, that water's got to go somewhere, right? The water that you spilled, it's going to spill on the floor, it's going to spill on the counter, whatever. But that extra is kind of like the extra in an improper fraction, right? You have more than one, but where's that extra stuff going to go? So that's what we're going to figure out right now. All right. So I'm going to go ahead and clear that up. So hopefully you guys copy this. If not, I'm actually going to post this to YouTube. I'll probably put a special label on it because it's not quite in the sequence of lessons. So I will probably maybe put this in all caps and, maybe I'll add this to Canvas also. Okay. So let's talk about improper fractions. So let's talk about that. So let's talk about mixed numbers. Okay. Hopefully everyone is okay with yellow. So let's talk about mixed numbers a little bit. I just want to make sure I stay in here. I don't get kicked out. So mixed number has a couple of parts, right? So a mixed number has, I'm just going to make one up. The number is not that important. We're just labeling parts here. So let's say I have something like 2.5, right? Right, you may have seen that before. If you, like I said, if you've ever done any baking or if you've used a measuring, like a measuring cup, not just like the kind that, not for solid measuring cup. I'm talking about liquid measuring cup, like the kind that pours, right? You know what I'm talking about, right?
Like the blender?
Yeah, like a blend. Exactly. Thank you. Okay, cool. So like a blender, right? So blender usually has measurements on that too. And so there's there's 2 parts to this, okay? So here, this big number, the 2, this is our what is called our whole number, right? Actually, I spent a good chunk of yesterday, last night, talking about what a whole number is, right? So a whole number is a positive number. It's a positive number, right? So I guess we could have negative ones too. It'd be weird, but I guess we could. But so this is our whole number, okay? So that's it. So that's, when we have more than one, that's just our regular counting numbers. 1, 2, 3, 4, 5, 6, 7, right? Whatever. But then we have this part right here, right? And this is our fraction. So there's 2 main parts to this, right? There's our whole number and then there's our fraction. That's it. So it's basically we have 2 of something and then we got a little bit left over. That's what we're saying here, all right? So, okay. Because ever, like if you had like an ingredient, like let's say you're making French toast and you need like 2.5, 2.5 cups of milk, right, to make it, right? So that means you got 2 of these, pour, right? And then you got a little bit left over, right? So you don't fill it all the way up, right? Okay. So, cool. Well, you're good on that? Now, here's the thing about mixed numbers is that mixed numbers are also equal to improper fractions, right? So let's take a look at how mixed numbers and improper fractions are related to each other. Because they are. Because either way, whether it's an improper fraction where the numerator is bigger, the top number is bigger, or it's a mixed number, you're still dealing with more than one. Things are spilling over, right? We have too much water in the ice cube tray. So let's see how this works. Let's go back to our 5/4, okay? So we have our improper fraction. So we have 5/4. So what we're going to do right now is we're going to represent this improper fraction as a mixed number. Remember, the reason why it's called a mixed number because it has a mix of 2 different numbers, right? It has a whole number and it has a fraction, right? So that's why we call it that. All right. So this is what we're going to do. This is how we approach this. Without using a calculator, right? What I'm going to do is I'm going to set this up as a division problem. Because remember, guys, fractions at its core, at its heart, are division problems. Fraction is division, division is fraction. Okay? Let's not forget that. That's one of the reasons why I like division so much because it's super, super flexible. So let's take a look at this. So I'm going to ask myself right now, how many times, well, actually, I'm going to set this up as a division. So remember, guys, so when we set up our division box, remember the numerator always goes, so the numerator becomes the dividend, right? Remember, the dividend is the number on the inside, okay? The divisor is the number on the outside. So dividend, divisor, okay? Okay. So I turn this into a division problem. Now, the reason why I'm setting it up like this is because it's so much easier to work with, okay? Also because the thing is, if, because I can ask myself now, okay, how many times does 4 go into 5?
Twice. 3 times?
Just 5. How many times does 4 go into 5? Once, right? It only goes in one time. Yeah, it only goes in once. Right? Yeah. So it only goes in once, right?
Let me think about it.
That's okay.
Today's Thursday.
Today's Thursday. No, no.
Like 3.
Real talk. It's Thursday, all right? It's,
Our brains don't have to.
right. That's why I got this in my hand right now.
Wake me up, but I think it is.
Okay. So 4 goes in the 5 ones, right? 4 times 1. That's what I'm doing here. 4 times 1, and I'm going to put the product underneath the dividend. I'm going to do a little subtraction, okay? So 5 minus 4 is 1. Okay, so we're going to use everything. We're going to use everything here, almost everything here. We're going to use this 4. We're going to use this 1 here. We're also going to use what's left over to put together our mixed number, okay? So we're going to use those pieces of information to do that. So this is how we do. All right, so this one right here, this number 1, this becomes our whole number. So the quotient, right, the answer to
1 and 1/4.
exactly, right, exactly. And this is how we get it. So that 1 is going to, that's going to become a whole number. Whatever is left over. Oh, remember how when we were doing basic division, right? Remember how we would have remainders and I was just like, dude, just put an R next to it and just write how much you have left, right? I said, because at that point, you weren't going to do anything with the leftovers, but now we are going to do something with the leftovers. So we don't have to worry about putting a remainder because our remainder is going to become this number right here. It's going to become our numerator. And guess what? See this denominator? This right here, guys? Right here, this denominator stays the same. So that's our denominator, and that we're just going to move it over here. And as Lorena said, yeah, so 5/4 is equal to, it's the same as 1 1/4. Okay?
Now I get it.
Mhm. So that's how we figured out those out, okay? So to turn an improper fraction to a mixed number, we have to do a little bit of division. And it's probably better if you just write it out instead of trying to do it with your calculator, especially if it's something like this, when it's like really low numbers.
Very complicated with like the bigger numbers.
Yeah. Well, once you get into bigger numbers, like if you get into bigger numbers, you can actually, yeah, you can do the same thing. Just use the technique, like use the techniques for solving double digit and triple digit long division problems that we kind of went over. And if you forgot how to do that, please let me know. I'll just remind you, right? Okay, so now we have our mixed number, right? Well, we can go back and forth, and oftentimes you're gonna have to, okay? I don't want to get kicked out, so I'm just gonna move things around a little bit. So give me a second. Okay. All right, so we have that 1 1/4, right? So I want to turn it back to a improper fraction. So because sometimes you're going to have to do that. Sometimes, like when you get to, let's say you get to a problem like this that we see right here in front of us, we see a little bit of, you may find yourself having to add a mixed number to a fraction, right? You may say, oh, hey, what happens when, you're baking a cake and, I'm terrible at baking cakes, so don't ask me to bake a cake, but let's say you're baking a cake. I tried baking a cake once and it was dry, like I didn't use enough eggs, okay? And let's say you have like, you have like 1.5 cups of, of water, right? Or let's see, that's the problem. I was using water. You have 1.5 cups of water, And then you got to mix that with, you know, 2/3 cup of, you know, 2/3, you know, of egg or whatever. Or butter, yeah, whatever. Okay, good. Thank you for making this a little bit more real. Right. So you got to mix those things up. So let's say you have like a 1.5 cups of milk, and then you have like you got 2/3 cup of butter, right? And you got to mix those together. Well, guess what? You can't do that because it's like apples and oranges. It's just like you got a mixed number and you got a fraction, and they're not going to go together until you make some changes. So what you could do is turn that mixed number, the 1.5 cups of milk, you can convert that to a fraction. Right? So that's what we're going to do here. So let's take, once again, let's take that 1 1/4 again, okay? So we have our improper fraction. Try to ignore this stuff on top for right now. So we have our improper fraction. So we have our 1 1/4 again, okay? So, yeah, absolutely. Because you are going to get here. Everybody gets here, right? If you've been here before, you're going to come here again. Because guess what? Fractions, like, because solving fraction problems, right, is going to be on the high set, right? It is going to be on the high set. And on the high set, it's going to assume that you already know how to do this stuff. It's not going to ask you to convert improper.
Remember now since changing a mixed number to improper.
Yeah, that's great. Yeah, that's fantastic. So this is good timing. This is a skill you should already know how to do. So in the high set, that's okay. That's why we got to keep practicing. That's why I'm coming back into it. So I don't mind repeating this lesson. It's actually a little fun for me. I have no life. And so like the high set, you will get tested on fractions like adding, subtracting, multiplying, dividing, but it will assume that you already know how to do this stuff. Right? It's not going to ask you to convert an improper fraction to a mixed number. It will assume that you already know how to do that to get an answer to a more difficult problem. This is like a step. Okay, so let's take a look at this. So we're going to take an improper fraction. We're going to turn it into a mixed number. Or I'm sorry. Did I totally mess that up, huh? Give me a second. Boo, 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 boo. We're taking a mixed number and we're turning it into an improper fraction. So I apologize for that. Hopefully you took your notes in pencil. It's Thursday, as you guys said. Okay. So we have a mixed number. I'm just going to put a number sign here. Okay. So this is how we do this, okay? So this time we have to do a little bit of multiplication, right? And a little bit of addition, okay? So this is the step. So this is kind of our, this is kind of our in-between here. Give me a sec. Okay, so what we're going to do is we're going to do a little multiplication first. First, we're going to take the numerator, okay? We're going to take this numerator and we're going to multiply. So I'm going to put a little X here for multiply. So we're going to take the numerator, we're going to multiply that by the whole number. You have to go. Okay. Yeah, I saw someone there that was kind of looking in here. Was that your ride? Oh. And then what you're going to do is you're going to get the answer, and then you're going to add the put a plus sign here. And so you're going to add that number.
Okay, so 4 times 1 is 4.
4. Oh, hey, look at that. Yeah, because 1 times 4 is 4. And that plus 1 is 5. And guess what we're going to get at the end of the day? 5, right? And that's going to be our numerator. So once we do this, this is going to come over here. And this is going to become our numerator. Now, the cool thing is the cool thing is our denominator is going to stay the same. Okay? So in the fraction part of our mixed number, the denominator is going to stay the same.
Be 5/4?
Yeah, there we go. Now we're back to 5/4 again. Okay? So that's how we do on this. All right? So I'll give you guys a moment if you have any questions, okay? So yeah, so getting this stuff down is really highly dependent on your ability to do this. This is one of those things you're expected to do. If you need additional drill help, let me show you where you can, like if you need some additional practice with this, I can point you towards the pages in Number Power where you can find that, all right? So, so real quick, so if I was to go to my course outline, and this is one of the reasons why I keep Canvas up here, is because I have these books. So going to, not decimals, although I did finish adding the decimals up here, so fractions. So here we go. So pages 19 and 20 and 21. So 19, 20, and 21 has those additional skills, okay, in Number Power 2. So if you're having issues remembering that stuff, yeah, that's where you're going to find some extra practice with this. And you might actually find some different techniques that might help you, get through it. Yeah, sure, absolutely. You're more than welcome to. So if the drills in,
Yeah, tell again.
okay, well, that's because it does that, if you do.
503 service unavailable like last time.
Well, that I'm not sure about. That part I'm not sure about. That's not it. That's definitely something not you didn't do that. Okay, cool. I'm just checking the time right now. Okay, now let's talk a little bit about equivalency, okay? Now we're going to get to the point where one of the things you're going to have to know how to do is to be able to check if fractions are the same, right? We just did a lesson yesterday, actually the last 2 weeks, on factoring and finding multiples, right? So, but we're gonna kind of go over to this now, because this is the one that's really kind of, I wrote this some time ago, but okay, so adding and subtracting fractions. There are 4 important steps. There's four questions that you have to ask yourself when you are adding or subtracting fractions, all right? The first, so I'll give yourself a moment. So if you want to, copy number 1 or, you got to ask yourself questions. And this is the thing that you should be doing, having a dialogue. I know it's going to be weird because maybe somebody will kind of stare at you going, what the heck are you, who are you talking to? All right, I'm talking to my math. That's what I'm doing. But you do have to ask yourselves these questions, and if you have to do it out loud, then do it out loud. I do it all the time with you guys. So I'm not just teaching, I'm actually trying to figure this out with you guys. So you got to ask yourself these questions. So once you see a problem, the question you're going to ask yourself, number 1, are the denominators the same? Hopefully we know at this point that the denominator is the number on the bottom of the fraction, right? So I put an example right here. So we have 1/2 plus 1/2, right? So if the denominators are the same, that's easy. This is like easy mode, right? I say there's 3 modes, okay? There's easy, there's medium, and then there's hard. Okay. Easy mode is when the denominators are the same, because all you have to do is you got to add the numerators and the denominator stays the same. So 1/2 plus 1/2 equals 2/2. Right? So we just add the top numbers. That's it. And then we have our answer. Now, we could take this a step further, right? I mean, 2/2 is also equal to what? It's also equal to 1, right? We learned that when the numerator and the denominator are the same, they equal to 1, right? Okay. Now, medium mode is you ask yourself, are the denominators the same? Now, if the answer is no, then we got to take the next step. If the denominators are different, can the smaller number divide evenly into the larger one? Right? So we have an example here. So we have 1/6 or 1/3 plus 1/6, right? So this is what we have here. So we're going to ask ourselves, so here we have 1/3 and here we have 1/6. And we ask, well, can that smaller number divide evenly into the larger one? And if the answer is yes, then we stop and we start doing some math, right? And we go, does 3 go into 6? Yeah, 3 goes evenly into 6, right? And remember, the math, because 6 is a multiple of 3, right? 6 is a multiple of 3, right? 3 times 1 is 3, 3 times 2 is 6. Yeah. So guess what? That's how we got that 6. So
what we just said?
well, this is what I like to do, and I'm going to actually add to my notes here. Okay. What I like to do, if I know, yeah, if I want my denominator to be 6, that's my goal. Okay. I want both of my denominators to be 6. So one of the things that I like to do, you guys, I like to think positively. Okay. Think positively. Thinking, all right, at some point in the future, I'm going to do it. I'm going to succeed. And I'm going to start rewriting the equation here. Watch. So I'm going to make the bottom one 6 already. Right? Because I know that's my goal. I have it in front of me. Right? And so now I'm going to ask myself, okay, well, I'm making that 3 into a 6. How did I do it? What did I have to multiply by 3 to get that 6? I have to multiply by 2. So 2 times 3 is 6. And then I have to do the same thing to the top, though. So whatever I do to the bottom, I got to do to the top. So I also have to multiply by 2. So 2 times 1 is?
2.
2. So that's going to become 2/6. So basically what I'm doing is I'm increasing the 1/3 to 2/6. And now, guess what? Do I have to do anything to this side? No, because guess what? It's already I don't, because it's already the denominator is already a 6, so I don't need to do any changes. I just need to change one sign.
3/6.
Yeah, it's going to be 3/6. Hey, yeah. Now I can add the. Now I can add the. Yeah, it's going to be the top, and then I keep the bottom. Now, the cool thing is, and yes, I would have to reduce this, right? You know, whenever when you're done solving a fraction problem, you always ask yourself, can I simplify? Can I reduce this? Yeah.
How do you simplify?
I just ask myself, what number do these have in common, right? So, for example, I have 3 and 6, right? So I ask myself, well, do these have a common number? Yeah, they do actually, right? And that is, so 3 can go into 6. It can divide into 6. Yeah, remember this is a this is, remember, fractions are division problems, right? So I can treat it like a division. Yeah, right, because 3 goes into itself once, right? And 3 goes into 6 twice. So if I was to simplify it,
That's why I have trouble too sometimes.
it would be 1/2, right? I like to talk my way through these a lot. It helps me remember. Um, that's how you do it. Remember, it's all division. It's all division. All right. Okay. Now that's easy mode because we only have to change one side, right? And well, not easy mode. It was medium mode because we only have to change one side, and we didn't have to do anything to this side, right? Because that was the our goal was to make it match with that. Now, however, we ask ourselves if the denominators are different, can the smaller denominator divide evenly into the larger one? If yes, that's fine. We just do what we did. However, if the answer is no, now we go into hard mode. And this is the part that just makes people run for the hills. But it's not that bad. What we have to do is find a common factor, right? We have to find a common multiple, really. So let's say we have 1/5 plus 5/7. Now, you got to ask yourself, okay, well, you may have to factor this. I'm not going to lie. You may have to factor it out, right? You may have to start going, okay, 5 times 1 is 5. 5 times 2 is, 10. Now, my advice is start with the bigger number because you'll get to it sooner. So let's go with 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is, no, that's not right. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. So 35 is a multiple. So you have to find a number that shares, because 35 is a multiple of 7, right? But 35 is also a multiple of 5. So 5 and 7 both share 35. So that's the one I'm going to go with. Right? That's because they have it in common. That's the C in LCD. It means common, right? It's the number that they both have in common. So thinking positively, I'm thinking, okay, you know what? Eventually, I'm going to have 35. My answer is going to have 35 as its denominator. So I'm just going to start writing it down, right? And then after that, then I'm going to figure out the numerators, right? And so on this side, I'm going to ask myself, okay, how did I get that 35 down here, right? Well, 7 times 5 is 35, right? That's how I got that 35 here. But I also have to multiply the numerator by the same number. So that's 1 times 5 is 5, okay? Now, then I have to do kind of the opposite here. I say, okay, how did I get that 35 on this side of the plus sign? I went 5 times 7 is 35, and I multiplied the numerator by the same number. And that's how I got that 7. So on this one, I had to raise both sides. I had to raise up both sides, right? Now, the crazy thing is that, these fractions, like 1/5 is the same as 7/35. They're equal. They're actually taking up the same amount of space. So if I think of ice cubes, right? So I think of that ice cube tray. Let's say I had an ice cube tray that I was able to make 5 really big ice cubes, right? And I only filled up like one of those, I only made one. Now, let's say I have the same size ice tray, right? But this time I cut it up into 35 pieces. There's 35 spaces, right? So same size ice tray, but it makes smaller cubes. So that's what yeah, okay. So that's what we did here is that it's taking up the same space. It's just that, the spaces are, yeah, the spaces are, there's more spaces. Now, and so that's what I had to do to make this work, though. That's what I had to do to make it work is I had to make the bottoms the same, right? And then so I just add the tops. That's going to give me 12. And then the numerator stays the same. So it gives me 12 over 35. Now I'm going to ask myself, this is a proper fraction, right? And I'm going to ask myself, well, can I reduce this, right? Can I reduce it? I don't think so. I don't know if 12 and 35 have a common number. Like I can try and, I can, but I don't think it does. 12, I don't think 12 and 35 share, because 35 has itself, it has 5 and 7, and that's it. Yeah. Right. And in this example, I did the same thing, except I did it with like 2/4 and 2/7, so the actions are the same. So what I did is, this is subtraction. So the difference here is that this is a subtraction problem. But guess what? We do the same thing. We have 2/4 minus 2/7, right? And so I said, okay, well, I have to find a common number that both share, 4 and 7. In this case, I said, okay, let's factor it out. That's okay. We can factor it out. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4, there's our 4. 7 times 4 is 28. So 28 is our common number. So both 28 shares 4 and 7. So guess what I'm going to do? Once again, going to be optimistic, and I'm going to start setting up my subtraction problem down at the bottom, right? So I'm already going to write my denominators, right? I just need to put my numerators. Now I'm going to ask myself, how did I get those 28s, right? How did I get those 28s on both sides? Well, to get this 28, I had to multiply 4 times 7. And that gave me 28. But, oh, I'm sorry. I have to take 7 times 4, right? So take a look at it. To get that 28, I have to take 7, multiply it by 4. That gave me 28. And then on the top, I took 2 times 4. That gave me 8 on the top. On the other side, I have to ask myself, well, how did I get the 28 down here? Well, I have to multiply by 7. So 7 times 4 is 28. 7 times 2 is 14. So now I have to subtract. This one, there's just one little trick, okay, that you have to remember. Try to subtract the smaller number from the bigger number. So when you set it up, remember, set it up with the bigger number first and then the smaller number, right? That will make it easier, okay? So here I have 14 minus 8. That's going to give me 6. Now, if you notice, so this was my answer here, 6 over 28. And I'm going to ask myself, well, can I reduce this? Yeah, I can. The number 6 can go into 28 a couple of times. In this case, 2 is a good one. So 2 will work for both of these. So 6 divided by 2 is 3. 28 divided by 2 is 14. And that's, I think, is as low as we can get it. Okay. So there you go, right? So that is how you can, so let's review, okay? So let's review. Let's go back a little bit. So remember, one of the things that, they're gonna ask you to do, I got kicked out of Aztec, so I'm gonna go back in. But one of the things you'll be expected to know how to do when you start adding and subtracting fractions is that you should know how to change an improper fraction to a mixed number to an improper fraction. You should also know how to simplify bigger fractions into smaller ones. So you should need to be able to find what is called equivalent fractions, okay? So those skills you will need to be pretty familiar with before you get that. Nice thing is that Aztec does kind of guide you through the process. So let me go back into that's why I ask you guys when you do this stuff is to do it in order. There's a reason why, because there's certain skills. I'm going to go back into pre-GED here. Here's fractions. Okay. So notice in this fraction basics, right? One of the things that they're going to go over. I'm going to mute this. So in this first chapter, right? In this first, not chapter, but this first lesson, it's important. Look at identify proper fractions, improper fractions, and mixed numbers. Right. We did that. And converting them, right? And we did that together. Find equivalent fractions, right? We did a little bit of that together too, right? Reduce a fraction to lowest terms, right? All this stuff right here is what you need to do before you start adding and subtracting these things. So this is a really super important lesson to make sure that you got all this stuff. And if you don't, even after the drills, please let me know. Or if you get stuck, please let me know so I can get you unstuck or I can give you extra practice. Okay. So, so let me know. Because we did all of this. Like when we were working on our notes, let me see. Yeah, like I had this one right here, 6/28, right? I had 6/28, and guess what we had to do? We had to reduce this to lowest terms, right? I had to figure out, okay, what number will go into both, and we said 2, right? 2 is a good one to start out with. Yeah, 2 is always a good one to start out with because a lot of numbers divide by 2. If 2 doesn't work, then nothing might.
14?
Yeah, it's going to be 3 and 14, right? So I would reduce this down to 3/14, and that's as far as we can go. This right here would be considered lowest terms. That's what we mean.
So we would have to figure out how many times it goes into something, or
Yeah, exactly. You got to find out,
we'll have to remember.
right. Does the top and the bottom number have a common multiple? Right? Check your
Multiplication chart.
your multiplication chart. Yeah. I was talking about this yesterday. Check your multiplication chart. Have it handy. Try not to, struggle too much with it. If you got the multiplication chart, use it for sure. Okay. So let me go into this a little bit. I'm going to dive in here because I already kind of went through a few of these things already, but I do want you to go through the lesson, okay? I really want you guys to do that. It is giving me such a problem here. Give me a second. Let me know if you guys are having connection problems. If not, what I'll do is I will, there we go. I think it's just being really slow. Okay. So let's look at slide 14. So we're going to look at, remember I talked about the ice tray, right? Well, this is our ice tray. Notice that our ice tray is the same size. It's just that one ice tray makes two really big pieces of ice, and the other one can make 8 smaller pieces of ice. But it's the same ice tray, right? It's like the same size. Right, but these are equivalent, right? So it's saying that this 1/2 is taking up the same space, is using the same water as this one right here, that's 4/8. That's how we can, that's the really key, really important to solving addition and subtraction problems. With fractions being able to do this, right? Now, how do you check that? Well, to check it, you can cross multiply, right? So what you do is multiply the numerator of the fraction by the denominator. And if the products are equal, the fractions are equivalent. Hopefully they'll show you right now. Okay, let's take a look at this example. Our 6/8 and 3/4 equivalent fractions. See, I love this, and see, they touched on this a little bit, Lorena, like in the high set prep, but like for a second. Here, they're giving you a little extra love here, okay? So it does pay to go down a level. So look at this. So we can multiply 6 times 4, that is 24. We cross multiply 8 times 3, that is 24. And hey, guess what? They're both equivalent. So the cool thing is, if I wanted to add or check this out, guys. Check this out. All right, real quick. Let's say I wanted to add these. I totally can. So let's say I wanted to set up this up as a addition problem. So I have 6/8 plus 3/4. Well, if I know that these are equivalent fractions, I can say that 8 and 4, if I factored it out, both have 24 in common. So guess what? Being the optimist, I'm going to go ahead and set this up. I already know my goal is 24. So, but to get that, what did I have to multiply? 4 times what is 24? You can check your multiplication chart. That's okay.
6.
6. So I'm going to put 6 here. I'm going to put 6 on the bottom and 6 on the top. So I know that 4 times 6 is 24. That's going to give me this one. 3 times 6 is
What is that?
3 times 6.
3 times 6 is 18.
Okay, that's going to be my numerator. Okay, so I finished this side. Okay, now the other side, how did I get 24 here? 8 times what is 24? 3, great. So 8 times 3 is 24. That gives me my bottom number. And so I also have to multiply the top number by 3 also. So 6 times 3 is?
18.
Great. So guess what now I can do? I can add these up. Very cool. So can someone do this calculation for me on a calculator? Can someone add 18 plus 18 real quick?
32.
Is it 32?
I think. Wait. It's 36.
36. That was close. That was super close. That was good. And you were just kind of throwing that in your head. Okay, 24 plus 24. Can someone kind of, bless you,
48?
48? Oh, yeah, you're right. It is 48, huh? Because if you put 4 plus 4, that's 8, and 2 plus 2, that's 4. Yeah. Okay, guess what? We have 36 over 48. Cool thing is, we can now, oh my gosh, this is so set up for us on a silver platter. Because now I can say, okay, I have 36 and 48. What number goes into both? No, seriously. And I'm going to say 12. I'm just going to give it to you, 12. So 36 and 48 have 12. So because 36 divided by 12 is, you can look at your times table. If you just find out 12 times what is 36?
12 times 3.
3, right? So that's going to be our top number. And then 12 times what is 48?
4.
4. Look at that. Now, we just kind of did a big circle here. We just did a big circle. I'm just telling you right now. Because guess what? Because we eventually, what we ended up with is 3/4, and that was one of the numbers that we started out with. But I just wanted to show you how powerful this skill is, and being able to, so when you get here to this equivalent fractions, please pay close note to it. Good. Please pay close attention to it, and make sure you write down everything. Okay, that's work the example. Work the example, guys. Okay, let me check the time real quick. Have you guys for a little bit longer. A lot of skill checks. Okay, so let's talk about reducing fractions to lowest terms. This is simplifying, right? Or reducing. Okay, so when you are working a fraction problem, right, and your answer is a fraction, you're going to ask yourself, can I reduce this? Can I simplify it to its lowest amount, right? That should be the last thing. I always forget, but you should, because let's say you're given a fraction problem on the high set, and you'll get something where you have to add, subtract, multiply, or divide, and it's going to give you two similar answers. One is going to be the answer in its higher form, but then you're going to get the same answer, but it's going to be in its simplified form. And the correct answer is always the simplified form. All right. So we need to know how to do that. Okay. So the numerator and denominator of a fraction are sometimes called terms. Okay. There's some vocabulary there. This is all stuff that you should write down. This is not a lot of text. Okay. Thus, reducing a fraction to lower terms means finding an equivalent fraction with a smaller numerator and denominator. Right? To reduce a fraction, you're going to divide the numerator and denominator by the same number. Remember what we just did with the 36 and the 48, right? So let me illustrate, because there's a lot of words here. I mean, it's not a lot. Like I said, you should be able to copy this down. But let's say we have that 36 over 48, right? 36 48. So to reduce that fraction, you're going to divide this numerator and denominator by the same number. In this case, we use 12, right? Here's our example. All right. And so what we end up with? We ended up with 3/4, right? And so this fraction so just really quick, I'm just kind of, see, this is one of the ways you can take notes, guys, is if you can use an example, it really helps. Like in this case, I just wrote up a fraction and I am using arrows to point to things. Like if there's vocabulary, I might, because this,
Right on that.
yeah, you should. Yeah. Because what I'm doing here is I'm kind of illustrating what is being written here. So I'm kind of turning the words to pictures. That's why I help. So if you can do that, that helps you remember things. You should do that.
You're recording it, right?
Oh, yeah. Oh, yeah.
Check it later.
Yeah, please. Yeah, I'm gonna make this one like a special one because I'm probably gonna have to record my geometry tonight because I don't think I'm doing geometry at all right now and today in this class. So I decided, okay, let's spend some extra time on fractions, so we're not as scared of them. So that 36 is called a term, right? Sometimes, right? That 48 is sometimes called a term. So these are called terms, right? And so what we did here is we reduced it. So the fraction has been reduced to lowest terms, guys, when no number except for one. This is really important. You might even want to underline that. Where no number except one will evenly divide into both. So that's why, remember how I said when we looked at 2, we had that 6 over, I think it was 6 over 28. And 2 was kind of the only one we could really do because the other ones weren't going to work. And once you get it down to a point where only one will work, like 3 divided by 1 is 3, 4 divided by 1 is 4, so it doesn't really do anything, we're done. We've gone as far as we can go. Okay. Any questions? Any questions here about this? So this shouldn't be, the reason why we're, and I'm going to tell you right now, the reason why this scares the crud out of this is we probably had a bad experience with it when we were in like middle school or something like that, right? Or grade school. And probably, I had a bad experience with it. It could have just been because, the teacher was just overwhelmed, which happens a lot. Is that the teacher just had too many students in the classroom. It happens. You got like one adult and you got 35, kids with different needs and wants and behavioral issues. There's a good chance that you might get just skipped over, right? Or maybe you just have a teacher that just didn't know exactly how to deliver this in a way that you could understand it, or they were forced to deliver it in a particular way because that's what the administrators said, right? Or it could be environmental, right? Maybe like at that point you were going through a rough time, right? It had nothing to do with your school. Maybe like you're going through a rough time. I know when I got behind in math, right? When I in the second grade, I was doing okay, but then at that point, my parents split up, right? And so it was really tough for me to focus. I mean, like I said, I'm autistic, and that's a huge and people with autism rely on routine, and when that routine is like disturbed and something like a divorce or like a separation, that's a huge disruption, right? And so that threw me off of math. So it maybe had nothing to do with the math, right? It was just a time in my life. It was just a difficult time in my life. For some people, it's not even the math. It could have just been something that was going on, right? You know, and it's not, maybe it's not the math that was the problem. Maybe it's not the fractions that we are afraid of. That's why I'm saying when we approach this, right? You know, I don't want us to be afraid of this. I don't want this to psych us out, right? That's kind of the idea here. All right. Okay, so let's go ahead and move on. All right, so let me go ahead and did we get this? I mean, I'm recording this, so you know. Okay, so let's go ahead and I'm gonna continue. See how much time we have left. It's 11:11. Make a wish. Okay, so we have 12 over 24. Look at this, and I like this one. We're gonna work it. I know it's given it to us, but I'm gonna work the example anyway because I want to make sure I understand what I'm doing. So reduce 12/24 to lowest term. So I'm gonna write 12 over 24. Choose a number that will divide both 12 and 24. Yeah, you can try 6. You definitely want to try try to find the highest number that will work for both because the higher.
Would work 12 work?
12 will work. Yeah, 12 will probably work better than 6 actually. Here they want us to use 6. 6 will work. But you know what? 12 will probably work better. You're right. Right? Look at this. They even tell us here. Look at this. It says you may want to look for the largest number because you can skip a step. Because if I use 6, look what happens when I use 6. So if I
Yeah, 12 better 'cause it's only.
it's
Well, either.
it's going to give me 2 over 4, right? And guess what I'm going to have to do?
Do it again.
I'm going to have to reduce again. So if you can find the highest number you can that will divide into both, that's even better because the higher the number, the lower the fraction. Okay. And of course, you can always check to see if if it works. Okay. So remember to cross multiply the check if, once you have your answer, what you can do is you can take your answer, multiply it by the original fraction to make sure that it's going to work out. Okay. So in case it does, right? So you get 24 over 24. That's fine. Okay. But my advice is work this. Work the examples. Okay. Now your question might be, how do I find that number though? Right? That's earlier in this lesson. So please don't skip over this. I'm kind of skipping over it because we already went through a lot of the earlier stuff, but please do go back into it because, for example, what we can do here is we can find the common factors. So let's say we have 24, right? Well, we're going to find our factors. Okay. 1 times what is 24?
1,
What? No, well, 1 times what is 24?
12,
1 times what?
2,
Let's take a look. 1 times what is 24?
24.
Yeah, there you go. There you go. Okay. And now let's look at 2. Let's try 2. 2 times what is 24?
12,
Okay, good. And 3 work? 3 times what is 24? Does that work?
yes, 8.
Oh, yeah, you're right. 3 times 8 is 24. Does anything else work? What about 4? 4 times what?
4 times 7 is 28.
4 times 7 is 20, but we're looking for 24.
4 times 6.
There you go. So we have 4 and 6. So this is how you can find your factors, right? Because at some point you're going to find a number that's going to work for both. Because you're like, this works for 24. Oh, that's cool. And take a look, guys. Take a look. See this right here? We already found it. we found this is the highest number that will go into both. So Lorena, see, look what we did there. That's the highest number that will go into both. That's kind of cool, huh? And we could do that and we could do the same thing for 12. Like if I want to use a T, I can go 12. Okay. 1 times 12 is 12, and then 2 times 6 is 12. And I'm like, well, this is the highest one that I can find. So 12. Oh, look at that. So if you're wondering how you can find, find that, you can use that technique. Okay. If you don't know how to do that, go back into the YouTube channel, look at the math lesson, not from this week, but from last Wednesday. From last Wednesday, we went into a lot of detail on how to use those, that chart. It's called a T chart. Yeah, you remember that one? Yeah, so if you go into the YouTube channel, look at last Wednesday, okay? So look at the video for, let's see, what was the date for last Wednesday? Last Wednesday was the, 16th. So if you look at the video for the 16th, you'll see how to find those numbers, okay? Okay. Okay, and the rest is skill check. It's rest is practice. I'm just running low on time, that's why. Okay, let's try this one. This is an easy one. They're throwing us a softball here, okay? Once again, I know softballs aren't really soft. If anyone's played softball and gotten hit with a softball, okay, you know they're not soft. That's a lie. That's a bold-faced lie. Like, hey, let's make a ball that's larger than a baseball, but just as hard, and throw it at people. Okay, so let's take a look at this. We have 9 and 6. Let's see if we can kind of figure this out. So we're looking for the highest number that will go into both. 3, right? So, and if you look at your multiplication table, you can kind of like, okay, 3, right? So what we're going to do is divide this. We're going to say, and remember, if you can't do this division, you can use your multiplication chart to figure it out, because you just ask yourself 3 times,
2.
right? So if you got to work backwards and use your multiplication chart, right? You can do that, all right? So 3 times 2 is 6. So that's going to give us 2 on the top. So 6 divided by 3 is 2, because, 3 times 2 is 6. And 3 times what is 9?
3.
Yeah, there you go. So 3 times 3 is 9. So we know that 9 divided by 3 is 3. That's going to be our answer. We can't go any lower than that, okay? Yeah, we as students should, I'm not saying we should learn to love division. We love our kids, right? But we don't have to love division, but we should embrace it and accept it, and know that we can do some amazing things and actually make our experiences with math, even going into algebra, right? It's going to be with us, Okay, so let's see if they'll give us one more. This one's probably going to be a little bit harder. Yeah, let's try this one. So we have 16. Let's try 16 over 20. Okay, so remember, guys, you got to find a number that they
4.
Both have a common 4? Okay. And we can check that later, right? So this time we'll do a check, okay? So 16 divided by 4 is what? 4. And 20 divided by 4 is?
5.
Okay. Now, I'm going to check and see if that works, right? So I'm going to once again put 16 over 20 and I'm going to cross multiply. So you might need your calculators for this. Yeah. Yeah, oh yeah. So so on a calculator, what's 5 times 16, you guys? Someone figure that one out.
16 times 5,
Yeah, 16 times 5.
80.
Is it 80? Okay. And what's 4 times 20? There you go. Yep. And so that's going to be the correct answer because it's equivalent. So 4 over 5 is equivalent to 16. Yeah, there you go. So that's how we do our check. Okay. Okay. Let's see how much time we have left here. We're running low on time. Okay, so let me, just gonna go in here and see. Okay. So yeah, we're gonna look at one more thing here, and once again, this is gonna prepare us for addition, subtraction, right? Multiplication, division for fractions is so easy because multiplication, division, we don't have to like find like common denominators or anything like that. We really don't. So raising a fraction to higher terms, meaning that you find an equivalent fraction, ones that are, like 16 over 20, right, was equivalent to 4/5, right? So what that means is when you're raising a fraction, it means you're taking a low fraction and you're making it bigger, right? Think about that ice tray again, right? Same size ice tray, right? But now we're adding more sections to it, right? So to raise a fraction, we have to multiply by the same number. So to bring it down, we have to divide. To bring it up, we have to multiply. Okay, so here it's the same thing. So we raise 1/4 to an equivalent fraction with a denominator of 20. Hey, remember when we were adding and subtracting? Remember how I like to put the denominators first? This is where that comes in, okay? So we were going to raise that that's our goal. We know the denominator is going to be 20, but we're got to ask ourselves, what number should be multiplied by 4 to get that 20? How did we get that 20 at the bottom? We have to multiply it by 5, right? So let me write this down. So once again, working the example, I said, okay, I have 1/4, and I know that my denominator is 20. We don't know what this is yet, but how did I get that 20? Well, I have to multiply it by 5. And guess what I'm going to have to do here? I'm going to have to multiply it by the same number. And so when we're done with everything, we're going to get our equivalent is going to be 5 over 20. So what we did is we took our ice tray, right? Our ice tray that only had 4 sections, and we added more sections. So now we can make 20 small pieces, if we need to, right? In this case, we only made like 5 small pieces of ice, right? Which is the same as one big piece of ice, right? Now I want to go home and make ice. The reason why I'm thinking of ice is because my kid took out the ice tray, right? Used the ice and forgot to fill it back up. I'm sure you've felt this pain before. And so now the ice tray is just kind of sitting on the counter. I'm like,
Same thing.
yeah, and I'm like, well, I'm gonna have to fill that thing up when I get home. So,
She bought little pumpkin ones and
uh,
they get it out of the freezer and they leave it outside. She gets mad.
yep, there you go.
So who you sell the ice?
Who you sell the ice? Where it's like, is there any more ice? Well, not anymore because our ice is now water. Congratulations. So yeah. Okay. So this is it. That's it. That's the last part of the puzzle here, or one of the last pieces. Okay. We need to know how to, let's review. So, in order to, and this is why a lot of people find adding and subtracting fractions a little daunting or intimidating, is that there's a lot of different skills that go into it, right? We need to be able to move back and forth between mixed numbers and improper fractions, right? We need to be able to take a fraction like with big numbers and reduce it. On the same time, we need to be able to, especially when we have we're trying to add two different denominators, we need to be able to, bring them both up so they're the same, right? So let's say we have that 1/4, right? Right, but we were trying to add, let's say, just for, we have 1/4, and let's say we wanted to add, let's see, let's try 5, no, let's try 6/20. All right, so let's say we have something like this. Well, if we have the ability to raise this 4 to have a 20 at the bottom, right? So if we know how to raise this to 5/20, guess what? We can now add that. There we go, all right? So this is, like I said, this is powerful stuff. So you're in pre-GED right now? Good. So when you get here, or if you haven't gotten here yet, please pay special attention to this first lesson in fractions, okay? If you need some extra work on it, I can give you extra work in Canvas, okay? If you need the extra practice. If you come to me next week and you're like, I'm still having problems with this, I'll say, okay, well, let's review first. And then if I need to give you extra work in number power, I'll do that, okay? All right. All right, guys. So next week, next Thursday, just letting you know, for those of you at home, because we have a lot of people at home. I'm gonna stop this. I'm gonna because I want this to be one whole video. So I'm probably gonna put this video in Canvas specifically because this is kind of out of our sequence. So I'll just make this special.